This question says, complete the following metric unit conversions. Be sure to use dimensional analysis and show it work. The quiz may ask questions about how dimensional analysis is set up. So in this case, we have to convert 68.1 milliliters to liters. So what we need to know is that 1,000 milliliters is equal to 1 liter. In order to use dimensional analysis to make a conversion, what we need to do is we need to know the relationship between the two variables. And as you'll see as we go on, this can't always be done in one step, but in this case it can be done in one step. So we have 68.1 milliliters to liters. So starting with 68.1 milliliters times, we need to put one of these two units on the bottom and one on the top. We want the unit that's going to cancel out on the bottom, the 1,000 milliliters, and on top we want the unit that we want, the 1 liter. To solve this, we multiply by the top, divide by 1,000. So we essentially divide this by 1,000. And when we do that, we get 0.0681 liters, like so. And you may have learned you simply need to move the decimal place 3 times in order to do this. And that will work for metric to metric equalities, assuming it's not always 3 times, but depends, assuming that you move it the appropriate number of places. However, dimensional analysis will work when you're converting things where you can't just move the decimal place. And as you'll see just in this example, there's several places where you can't just move the decimal place. And in chemistry questions, it's almost never as simple as just move the decimal place, unless it's exactly these conversions. All right, next one, 1.51 kilograms to grams. We need to know the relationship between kilograms and grams. Well, 1,000 grams equals 1 kilogram. This is called an equality. This is called a conversion factor. So we can write it as a conversion factor. So if we start with our 1.51 kilograms, we want kilograms to cancel out. So we decide how we're going to organize these variables. And how we're going to organize them is, so kilograms are on the bottom, and the 1,000 grams are on the top. Now, if you recall, we are saying that these two things are equal because they are. So now we have an equal thing divided by another equal thing. Said another way, this is essentially 1 because these two things are equal. One thing and divided by an equal thing gives you 1. So we're not changing this quantity of the 1.51 kilograms. We're simply changing the unit to grams. So now when we do that, what we end up with is 1510 grams. Technically speaking, if you still wanted this to be 3 sig figs, you should write 1.51 times 10 to the 3 in scientific notation, grams. And we talked about that earlier. Next one, we have 512 nanometers to meters. This comes up in the chapter about quantum mechanics. So nanometers are 1 times 10 to the 9 nanometers, which is a billion, equals 1 meter. So if you've heard of nanotechnology, nanotechnology is on the scale of 1/1 billionth, okay, of a meter, because a nanometer is essentially 1/1 billionth of a meter. So it's a very, very, very small thing. So I'm not going to get into it too much detail here. So if we start with our 512 nanometers times, we want nanometers to cancel out, so we put 1 times 10 to the 9 nanometers on the bottom, and we put the 1 meter on the top. Now it's really important because we're going to basically multiply by 1, which we don't need to do, and then we're going to divide by 1 times 10 to the 9 in the calculator. If you're using a Texas Instruments calculator, you would type in 1EE9 for this number. Okay, if you're using a Casio calculator, you would type in 1EXP9. What you're going to see on the screen, sorry, you can't see that, 1EE9. What you're going to see on the screen of a Texas Instruments calculator is one with 1E and a 9. If you're using a Casio calculator, it'll be like 1, and then there's usually on the side times 10, and then it might be 0.9. I'm not sure if it's 9 or 0.9, but it's basically this kind of thing. So this will help you because when you're dividing by this number, it could be an order of operations problem. If you just type this in as 1 times 10 to the 9, what your calculator is going to do is take this, multiply it by, divide it by 1, and then multiply it by 10s to the 9. And instead, you want to divide by 1 times 10 to the 9, so it's important to plug it into your calculator correctly, and this will come up in other cases. So that's basically that. And when you do this, what you find is that you get 5.12 times 10 to the minus 7 meters. So this is how we can convert metric units. By knowing the equality, we can turn it into a conversion factor. In all cases, the unit we're trying to get rid of is on the bottom, and to solve, multiply by the top, divide by the bottom. If it's a 1, you don't have to bother with multiplying or dividing by 1.